download our Revise It Right revision app for hundreds of videos, quizzes, exam questions, tutor support and so much more. This video is about the modern periodic table. Now, as we know, the periodic table is now ordered in terms of its atomic number, and this was due to the discovery of the protons. So, for example, we've got 1, then 2, then 3, 4, and so on. And that number represents how many protons an element has. So, beryllium has 4 protons, and sodium has 11. This was very similar to Mendeleev's periodic table, and remember, he came up with his without knowing anything about protons, neutrons, and electrons. There are no gaps now, however, because all the elements have now been discovered. And due to the discovery of electrons, elements are now grouped according to the number of electrons in their outer shell. Because this tells us how an element behaves and how an element reacts. So for example, those found in group 1 will have 1 electron in their outer shell. And we know that if you only have 1 electron in your outer shell, you will be very reactive. And therefore group 1 elements are very reactive. Group 2 have 2 electrons in the outer shell. Group 3 have 3 electrons. Group 4 have 4 electrons, and so forth and so forth. So the group number tells you how many electrons there are in the outer shell. Again, this was very similar to Mendeleev's idea of grouping elements due to their properties. Now, you can also use the periodic table to tell you the electronic structure of elements, because as we stated before, the group that an element is in tells you how many electrons are in the outer shell. So again, it means that an element in group 5 has 5 electrons in the outer shell, and an element in group 7 has 7. As well as this, the period an element is in, okay, so remember our periodic table is arranged in periods, so we've got period 1 up here, which is hydrogen and helium, period 2, period 3, this is period 4, period 5 is here. Okay, so this, for example, that's period 5. And you can see it's arranged across. Now, the period number tells you how many shells an atom will have. For example, an element in period 3 will have 3 shells, and an element in period 2 will have 2 shells. So then we can pick out any element. So, for example, let's pick out boron. Now, we know boron is in period 2. So we know that boron is going to have 2 shells. And we know that it is in group 3. So we know that you're going to have 3 electrons in the outer shell. And we know it's got 2 shells, and therefore that will be the electronic structure of boron. Remember to download our Revise It Right revision app, watch over 700 videos, answer 4,000 plus quiz questions, over 1,000 flashcards, 1,000 exam questions, worksheets, forums, and get help from qualified teachers, and so much more. The link is in the description. Let's try again. Let's do potassium. Potassium is in period 4, so we know it's going to have 4 shells. We also know it's in group 1, so we know it's going to have 1 electron in its outer shell. And therefore we know that every other shell is going to be full. So we know that this is going to be the electronic structure for potassium. So it's important to understand here that the group number tells you how many electrons are in the outer shell, and the period number tells you how many shells the electrons have. Now, also with the periodic table, it's very useful at telling us if an element is a metal or a non-metal, because metals are usually found on the left. You may often see a staircase here. Metals are found here. So any element that exists in this region here is a metal, and then we got non-metals on the right of the staircase. And we'll talk about this more in the next video. Now, as I said before, all atoms want a full outer shell, and this is why they react. The whole purpose of them reacting is to gain that full outer shell. Therefore, elements that contain the same number of electrons will react in a similar way. So this means that all elements in group 1 have 1 electron in their outer shell, and that therefore explains why they all behave in a similar way, that they're all very reactive, because they all have the same amount of electrons in their outer shell. You can also predict the reactivity as you go down a group. This is called a trend in reactivity. For example, in group 1, elements get more reactive as you go down. And in group 7, on the other hand, elements get less reactive as you go down. And we're going to explain these in the next few videos. But for now, just understand that this is why elements in the same group behave in a similar way, because they have the same number of electrons in their outer shell. Here are some summary questions. Pause the video to have a go. Okay, so in the modern periodic table, elements are arranged in order of what? Their atomic number, which is of course the amount of protons they have. Where do you find metals? To the left of the staircase, and non-metals to the right. How many electrons are in the outer shell of an element in group 2? It's of course 2. What are the rows called in the periodic table? They are called periods. And how many shells are there in an element in period 3? There are 3 shells. So an element that's in period 3 and in group 2 will have 3 shells and 2 electrons in the outer shell. So we've now looked at a video on the modern periodic table. There are plenty of practice questions on the website, and as ever, if there's anything you didn't understand, get in contact with a tutor who will happily help.